find, consider two vector a bar and b bar. If the vector a bar is rotated towards b bar, then we have a cross product of a bar cross b bar, which is going perpendicular to the given plane. So a bar cross b bar equal to mod of a into mod of b into sine theta into unit vector along a bar cross b bar. This one is the same, n cap a bar cross b bar, and rotation will take place in this way. But if you imagine that b will rotate towards a, if b will rotate towards b, a, then will your index finger will go this way, correct? If a b is rotated towards a, index finger will go downward. So this quantity is called as b cross a. A cross b and b cross a, are they same quantity or they are exactly opposite quantity? They are exactly opposite quantity. One is going upward, second is going downward. So this is a very useful rule. You cannot carry out a cross b as b cross a. If you want to carry out, you have to use minus sign. Minus sign indicates that they are acting in the opposite direction. So a bar in general is given by axi plus ayj plus azk, and b bar is given by bxi plus byj plus bzk. If you want to carry out a cross product, a bar cross b, so this one is I, this one is j, this one is k. First row is for a, ax, ay, az, bx, by, bz. All of you know how to solve determinant? Is considered is the moment is defined as force multiplied by perpendicular distance. So moment of the force C, this is defined as force multiplied by shortest distance, and is this force above this point will rotate in a clockwise. So your sign convention is this. So basically this one is vector quantity because it has a magnitude and it has a direction. The smaller distance will drop perpendicular from this smaller distance. So this smallest distance is distance between F and C. Is it correct? I want to use this concept for three-dimensional. For this purpose, I will join A and C. A and C will make an angle equals to theta. Is this length is mod of CA. If I say consider this vector, mod of CA. So this way and this 90 degree. So is this term D right now, is it mod of CA multiplied by sine theta? So this one is sine theta. So if I replace this D, then I will get moment of the force above C. Is it F multiplied by, this F is same as mod F is multiplied by what? CA. Is it multiplied by sine theta? Now look at this term and look at this term. Is it one and same term? And this unit vector will take care of the vector quantity. So I will just write this one as bar. It automatically take your vector perpendicular to this plane. So this force will rotate like this one. So what is this quantity? This quantity was written like this: moment of the force above C. I will just change the order to satisfy right hand rule. So first you have to write down C, A, then you have to write down F bar. Is it same as A bar B? A cross B. Now CA cross F bar will satisfy right hand rule. So you must have an order like this. Now how are you going to remember? You will remember like this: moment of the force above C. So your first letter is C. Second letter is any end point of force F, either A or either B. So I will write this time A cross F bar. Now second is also true. Now why the second is true? You can check this from this figure. If I join this point with this one, then is this vector is equals to mod of CB. And if I take this angle is phi, then is this distance D, can I write as mod of CB multiplied by sine phi, and is it same as mod of F into mod of CV into sine phi, and therefore can we write this term equals to as CB cross F bar. And how quickly you can remember is moment of force above C. So my first letter is C, and you can take any one letter of the force. Now this time I will prefer B. CB cross F bar. Your answer will not change. So there is no rule whether you take point A or you take point B. I repeat this last time. Moment of the force about point C. So first letter is C. Second letter you can select any end point of force. So I will select A cross F bar. And if I have first letter equal to C, can I go for B also? Both answers will be same answer. It is proved mathematically from this. Clear? And you have to always write down bar. Bar means what? Vector quantity. So now moment vector is normally represented by double arrow, and single arrow is used for force. And you have to write down this one as moment of the force about point C, and this is passing through point C. And the force, so use single arrow. So this one is representation of force vector. If you want to make distinction between the moment, use double arrow. This point is A point, this one is B point, and this one is point C. Your moment vector is calculated at point C. If we want to find out moment force vector directed from A to B, and we have origin O point. So you have to join this O with this. This vector equals to what? OA. Moment of force about origin is a vector quantity is equals to O, one end point of force A cross F bar, or one end point is O, second one is end point of force P cross F bar. Then yesterday we have seen how to calculate F bar. Is F bar is equals to F multiplied by unit vector along AB. What is unit vector along AB? Is AB bar upon mod of AB bar. So how many vector you have to find out? Two vector. One is OA and one is AB, or O and AB. Vector is called as moment vector. About which point? O point. You want to find out what is the moment of this force about any point C. To form this one, we have to first join C with A, and you have to first obtain vector CA. We are going to write down this moment of force about point C will be equals to C first, then any letters of F will be CA cross F bar. Can we write CB cross F bar also? We can write CB cross, right, moment of the force about the line CD. We wish to find out moment of the force about line CD. So this one is one force acting from A to B and has a magnitude of F, and the vector is represented by F bar. As vector equation is CD bar. Moment of force about line CD, what you do first, you first find out the moment of force about point C first. Either C or either D, any one point that you obtain first. Now once you obtain this one, so this one is your step number 1. Obtain the moment of the given force either about C or either about D. That is step number 1. So you have to perform this step first. Once you perform this step, then you can represent your vector like this. So this means that it's a projection of moment of force C on CD. That is the true meaning of this one. It means that you have to project this quantity on which line? CD line. So whatever you get now here, this quantity will be, one quantity is moment of the force above CD. Why not vector quantity? You can check it. What is the projection is? Is it a dot product? Projection is what? Dot product of means as it is, on means unit vector. Correct? So you can write this quantity as moment of force above C is okay, multiplied by unit vector C. Agree? So you can split like this. So in first step, whenever you have to find out moment of force above CD, carry out the step number 1 first, that is find out moment of force above C. Once you find out this vector, take the projection of this vector on CD and then you carry out the dot product. So your answer is this. And how you quickly remember this? You remember like this, moment of force above CD. So you can split this word and write this quantity as moment of the force above C. This one is vector quantity. And in second step, you consider these 2 points and then write dot product of unit vector C. So is it one and same? I have given you how to remember it. Now this one is scalar quantity or dot product? This is a vector quantity. And if still you are interested, what is my moment quantity about this one? So whenever you want a vector, vector is always defined by scalar multiplied by unit vector. So what is the scalar quantity? Scalar quantity is this much, that is moment of force above CD multiplied by, what is the unit vector along this one? Is it n cap CD? So this one is n cap CD. If you want to find out projection of F bar, so what is the projection means? Dot product. Off means F bar. On means unit vector CD. Is it fine? Okay, one more final concept, that is called as position vector, right? Position vector is a vector obtained. A position vector is a vector obtained by joining the given point with respect to origin. With respect to origin. R bar is normally represented by R bar. Now we are given a coordinate system here and we know the one point A equal to XYZ and we have one origin. If you join this point with this point, then you can call this vector as, either you can call it as OA bar, or you can call this simply as R bar of point A, called as position vector of A. Is this position vector is x minus 0 xi, y minus 0 yj, z minus 0 zk. So is this position vector is same as the coordinate of given point. So if you know the coordinate, you can write position vector, and if you know the position vector, can you write down the coordinate? Say for example, I have R bar equal to 2y minus 3j plus 4k. So can I conclude the coordinate of this point A equals to 2 minus 3 comma 4. So data they will not provide in this form, data they will provide in this form. They are mutually convertible. Coefficient of I will be x, j will be y, and k will be z. Is it fine?